So once again, good evening and welcome to the Quat Live Collab sessions. Today we're looking at Learning Unit 4, and I have here, as you can see, a worksheet that is covering all of which you will see in Learning Unit 4. It's a typical type of question that you can expect in your assignment as well as your exam. So it really is a good indication of how the question is set out. And you'll see that again if you are, like for you, Stephanie, you're live on the session. You can download the document that is up on the screen, but I will also upload it to VC Learn to the revision folder. But if you look at on your screen, the top right hand corner next to the bin icon, you'll see an icon that looks like this with an arrow. And this enables you to download the document that is currently on the screen. So if you would like, you can download that. And you'll see there are two examples. It is the one on this page that you can see, and then the one on the other page. And I will just be working with the one, and I will give you the other one here on this page for you to practice as an additional example, so you can get a feel for doing this on your own and familiarize yourself with these type of questions. So I'll be going through just this question for today. Yes, it is a new feature on Blackboard, and it really is quite useful if you're live on a session. So it makes it easy for you to just download whatever is up on the screen, and you can immediately just work with it. Okay, so let's have a look at this question. So this is to you that an investment analyst, sorry, before I continue, remember this is Learning Unit 4, which is a section called Linear Regression and Correlation Analysis. So it is one of the easier sections. It's quite straightforward. It's also one of the ones that is quite easy to get good marks in. So it's not something that you will really struggle with. I honestly have seen students get their best marks in a question like this. So it really is quite a straightforward question, easy mark, something that you won't have a difficult time with. And you can also bank on something like this in an exam and know that it's something that it will play to your strengths. So you really shouldn't have a difficult time with this. In terms of entering it onto your calculators, it is pretty straightforward as well. It's the same idea as any of your calculations. So there's a fraction involved and so on. You'll see that as we go along in the calculation. And then there's also a way for you to use your calculators to actually calculate some of the answers that we will use, that we will be working out ourselves here manually. So that's advantageous because you can use the calculator to double check that your manual calculation was correct. And then also sometimes you'll find in an assignment or an exam, they actually say to you specifically to make use of your calculators to calculate certain variables. So it is quite useful to have that option. And I think I actually have already uploaded a worksheet that you can refer to under your, I think it's a case studies and activity folder, if I'm not mistaken. It is a calculator worksheet, which basically helps you with Learning Unit 3. And part of it also helps you with Learning Unit 4, which is this linear regression and correlation analysis. It's a step-by-step guide telling you how to enter some of the figures, like some of the information you see up on the screen, for example. Whatever's in this table, you actually enter this onto the calculator and it will generate the values that you are generally asked to calculate. So that I will just double check if I have uploaded it. If I've not uploaded it, then I will do so. But it is extremely useful to have that option available to you because, as I said, it's just a way for you to be able to check that your answers are correct. And sometimes, as I said, they will ask you to specifically use your calculators. So that obviously is something you would need to know, the steps involved in entering these values onto the calculator and generating your answers. So I will upload that if I haven't done so already. Please can I ask that you do refer to that worksheet and use it for learning unit 3 as well as this learning unit 4. It's a step by step, so it hopefully should be quite simple and straightforward and quite useful, because along the way you can just follow on the worksheet and you'll know how to enter the respective values. Okay, so it's not on VC Learn. I will upload it and you can just play around with that and try it out with an example or two and familiarize yourself with the methods to calculate certain values. And naturally, you will need to know the steps because you won't get that sort of guide in your papers, in your exam, that type of thing. It's not obvious. It's obviously not going to be in any formula sheet or anything of the sort. So have a look at that worksheet when I've uploaded it. I will send out a notification to let you know that it is uploaded. Okay, so let's go back to what you see up on the screen. So this is, as I said, Learning Unit 4. It's a section called Linear Regression and Correlation Analysis. And what we look at here is the relationship, if there is any, between two variables. And we quantify the relationship through linear regression, meaning we identify, is there a relationship between two variables? And then we create an equation, a model to help us explain that relationship. And then once we know if there is a relationship, through correlation analysis, we then identify the strength of the relationship between the two variables. So essentially, this learning unit is about two variables where we're trying to identify, is there a relationship that exists? And if there is a relationship that exists, then we want to know, is it a strong relationship? Is it a weak relationship? And is it a positive relationship or a negative relationship? So section A here says that an investment analyst wishes to determine the strength of the relationship between the amount that individuals spend on cars. So that's the first variable, the amount that individuals spends on cars, and their annual income. So those are the two variables that we are looking at here. And then you will see that in the table, they've actually given you those two headings as well, because that is the information provided. They've given you the annual income in the first column. And then in the second column, they've given you the value of the vehicle. So the amount that individuals can spend on a car based on their income. So this is the information that was obtained from a random sample of 10 families. So automatically, before even moving on, from that information, they said to you there was information based on the spending habits basically of 10 families. This would tell you that your sample size n is equal to 10. So now we look at the information in the table. As you can see, your annual income in the first column, and then the amount spent on a vehicle in the second column, or the value of the vehicle in the second column. So under the questions, the first question asked you to identify the dependent and the independent variables. So here, in terms of dependent and independent variables, the X variable is always the independent variable and the Y variable is your dependent variable. So between these two, to ask yourself the question of which variable depends on the other. And this is how you're going to be able to answer which is X and which is Y. So you have two variables, X and Y. One of them is independent, the other is dependent. Independent, literal to the word, means that this variable can stand in isolation. It's not dependent on anything else. And then you have your Y variable, which is dependent on your X variable. So between the two variables, annual income and the value of the vehicle, you need to now identify which of them is X and which of them is Y. So you're going to always ask yourself the question in this manner. You're going to say, does the annual income depend on the value of the vehicle, or does the value of the vehicle that is being purchased depend on your annual income? And then it automatically sort of becomes obvious to you when you ask yourself the question in that way, where here the value of the vehicle that's being purchased depends on a person's annual income. So here, your value of your vehicle is the Y variable. This is the dependent variable. So vehicle value would be Y, and the annual income will be your X variable. So always ask yourself the question like I had here, and in this example, it was the two variables was annual income and the value of the vehicle. Ask yourself the question of, does the value of the vehicle depend on the annual income, or does the annual income depend on the value of the vehicle? So here we know then that the Y variable is the value of the vehicle, and I'm just going to erase that and write it again here. At the top, I'll make this Y, and then this will be X. So your annual income will be X. So we've done question 1. Let's look at question 2. So question 2 says to you to determine the values for A and B in the equation for the regression line. So the equation of the regression line, I'm going to write the formula next to it. It is y is equal to A plus bx. So in this formula, all it's saying to you is that they want you to calculate the values for A and B. And here there are specific formulas that we will need to follow. So if you look at the information provided at the top, you have the values for X and sorry, I think I got cut off there for a second. So as I was saying, in the table that was provided to you, you have the variables X and Y. Now to even get started with calculating the values of A and B, the first thing we need to do is extend the table at the top. Now I'm going to just add on columns here and extend it. And in an assignment or an exam, you can do the same, but generally they do allocate marks to this. So generally you'll be given the two columns that you see up on the screen, and you'll have to copy it into your answer booklet and then add on the 3 additional columns. 9 out of 10 times they'll give you the two variables and they'll say to you, calculate, like you saw here, the value of A and B. A and B are also known as B0 and B1. You'll also see that in your formula sheets at the back of your assignment question paper. So you can have a look at that here as well. So here you will redraw the table and you're going to add on 3 additional columns. Now the reason I'm saying 3, even though you don't always use all 3 columns, but the reason I'm saying 3 is because sometimes they ask you to calculate A and B, and then also to calculate R, which is your correlation coefficient. You'll see that here in question 5. So in order to calculate the correlation coefficient, you'd need the third column as well. So I'm going to just add on all from now, just to make it easy as we go along. So you'll need to add on 3 additional columns, as I said. The first column is going to be x squared, then it's going to be xy, and then the last column is going to be y squared. And then you're also going to add an additional row at the bottom, because at the end we're going to have to sum up each of these columns. So let's get started with filling in the figures in this table. And then once we have that, it will enable us to calculate the value of A and B. So x squared, the first block or the first additional column, is literally squaring each x value. So for example, 280 squared will give you 78,400. Then you have 125 squared, which will be 15,625. Then you have 141 squared, and then 234 squared, 197 squared, 201 squared, 116 squared, and so on. So I'm going to write down the answers for you here. So the next one was 19,881. Then it was 234 squared is 54,756. Then 197 squared is 38,809. Then 201 squared is 40,401. 116 squared is 13,456. 195 squared is 38,456. 195 squared is 38,025. 168 squared is 28,224. And the last one is 221 squared, which is 48,841. So now you've squared all of your x values. The next column has x, y. So remember, when there's no sign between variables, it's a given that it's multiplication. So this technically means it is x times y. So it's each x value multiplied by its respective y value. So it's 280 times 320, which would give you 89,600. Then 125 times 150, 141 times 100, 234 times 220, 197 times 65, and you'll continue like that. So the next one is 125 times 150, that's 18,750, then 14,100, then 51,480. 12,805, 29,145, 5568, 14,625, 15,456, and the last one is 61,880. So now you're done with the x times y column. The next is your y squared. So your y squared, just like we had done with your x squared, is literally just about squaring your y value. So 320 squared, 150 squared, 100 squared, 220 squared, 65 squared, and so on. You'll square all of them. So 320 squared is 102,400. 150 squared is 22,500. Then 100 squared is 10,000. 220 squared is 48,400. Then 4225. 21025. 2304. 5625. 8464. And the last one is 78,400. All right, so once you're done with that, we can now add up each respective column. So this in the front, your first column, is x, so it's the sum of x. You will literally write it down exactly as you can see it here. It's the sum of x is equal to, and you're going to add up all these numbers. So this gives you a value of 1879. Then the next one is summing up all of your y variables. So the sum of y is equal to, and here it's 1495. Then your next column, which is the sum of x squared, is 371, 370, sorry, why am I writing 1? 376, 418. This is the sum of x squared. Then your xf is x times f. So here, sorry, your xy is x times y. So here your total is 313409. So that's the sum of xy. And then the last column is your sum of the sum of y squared. So the sum of y squared is 299,118. Okay, so now you have everything necessary to calculate pretty much everything that you would require under your ungrouped data. So this question that we were actually looking at now had the values for A and B that needed to be calculated, and it was remember y is equal to A plus bx in terms of the formula, and we said that we needed to know the value of A and B in the formula. So in particular, and I'm just going to highlight that, we needed to know the value of A and B in the formula. So to calculate the value of A and B, we needed to draw up this table, remember? And then once the table is drawn up, we will apply the following formulas. Now between A and B, B must always be calculated first. So please make note of that. B must always be calculated first. So the formula is B is equal to n times the sum of xy minus the sum of x times the sum of y. And then it's over n minus the sum of x times the sum of y. And then it's over n times x squared minus, oh, this pen. What is wrong with this pen? Sorry about that. Okay, so this is the formula for B. So it's n times the sum of xy minus the sum of x times the sum of y over n x squared minus the sum of x squared. So here let's break it down and identify what actually goes into this formula. And then once we have the value for B, we can then calculate the value for A, which is then calculated as the sum of y sorry, it zoomed out a bit there. Okay, so it's the sum of y minus b times the sum of x over n. So we know the formulas for A and B. We can now pull through from the table and substitute for the values of X and Y. So we always start off with B, as I said. So this would mean, and I'm just going to do it next to it here so that we have enough space. So here it's N, which is, they said to you that this was a sample of where am I reading? Here. Okay, so this was a random sample of 10 families, meaning you have 10 values altogether. So N will be 10. So I'm going to write down here 10 times, and then it's times the sum of x, y. Again, remember there's no sign, so you don't need to do them. There is no sign, so it's a given that it's multiplication. So that's 10 multiplied by the sum of xy, which is here. So this is the sum of xy. It's 313409. Then it's minus the sum of x times the sum of y. So the sum of x is the 1879 that you had calculated here, multiplied by the, sorry guys, I think I got cut off there, but the reception is a little bit bad. So I was saying that it's 1879 as your sum of x times your sum of y is here, the 1495. Oh, sorry. Let me just erase that. Okay. So times 1495. And then this is over n times, so 10 times the sum of x squared. So the sum of x squared was already done for you here. Here's it here. Below it, the sum of x squared. So this is 37,600 and 376,418. So here you're going to say 10 times 376,418. And then it's minus. And if you look at this, it says to you the sum of x then squared. Now this is different, and I'm going to highlight it in the formula. This x squared, the sum of x squared, is different from this sum of x squared. The reason for it is because under the first one, which is your sum of x squared, it's where you've squared all the x variable, like in this column. You've squared all the x variables and you've added that up, and that's how you got the 376,418. And then the difference between that and the sum of x squared, which you see in the next block, it says it says the sum of x then squared. So what you're going to do here is you're going to then add up the x first and then square that value. So this is the main difference between the n squared here, the x squared here in your formula and here. So the first one, n times x squared, is where you have, sorry guys, I think I got cut off there again. Yes, so I got cut off again. I'm not sure what's going on. I think it's the reception. So sorry about that. So yes, I was saying the difference between the sum of x squared here and then the sum of x squared here is that with the first one, where it says n times the sum of x squared, this is where you square the x values first and then you sum it up. The second one, which is here, I'm just trying to circle that. The second one, which is here, is where first you add up the x and then you sum up that, then you square that total. So there's a difference between the two because the first one is in this column, as I said. Here you square each x value and then you add them up. So you're doing the squaring first and then you're adding up after that. With the second one, which is here in this formula, the second x squared, here instead of summing up last, you do the summing up first. So you sum up all the x values and then you square that answer. So then when you sum up the x values, it's here at the bottom, the 1879. So it's 1879 and then you square that value. So that's going to give you an answer of 1.39 as your B value. And so you have your B value now, you can move on to the value of A. So A is calculated using the formula that you see up here. It's the sum of Y minus B times the sum of X, and that's over N. Now you see why it's important that here you had the value of B calculated first, because this value of B is needed for the formula of A. So you would have needed to always have calculated your B value first. This is why it's a general rule to calculate B first and then A. So it says the sum of Y, and I'm going to do it. Let me see where I have some space. Okay, here maybe. Okay, so you have the sum of Y, which is here in the second column, and that's 1495 minus B, which we just calculated, goes in here now, so that's 1.39 times, then you have the sum of X in your formula. So here is the sum of X, and the sum of X is here at the bottom, the 1879. And then you have N in your denominator. N is 10 because this said that you sampled 10 families. So it's 1495 minus 1.39 times 1879, and that's over 10. So as your value of A here, it's going to be minus 111.68. And I'm going to write that, where can I write it? Just below it. So 111.68. And then now you're going to take those values for A and B, and you're literally just going to plug it in to the formula. So into your formula, in place of A and B, you are now putting, yes, so it's totally normal. It's very common. It is totally possible for A or B to be negative numbers. It doesn't have to be a positive number. And when you are entering it as a negative, if it ends up being a negative, you need to enter it exactly as that into the equation as well. So for the equation y is equal to a plus bx, we calculated that a is now the negative 111.68. So you'll say y is equal to, and because it's negative, you leave it as a negative. So you'll say y is equal to, and because it's negative, you leave it as a negative. So 111.68. And then you have your b variable as, so it's attached to the x. Let me just see if I can move this a little bit this way so I can write it out. Okay. And then it's plus bx. So b is then the 1.39 that we calculated here. So it'll be plus 1.39, and then you'll have the x here. So now you have the value for a and b in your formula. Any questions so far? Okay, cool. So that's your value of a and b. Question 3 then asks you to interpret the b coefficient. Now, the b coefficient is literally the value of b in the formula y is equal to a plus bx. So literally the b that you see here is your b coefficient. It's referred to as your b coefficient. So before I write down, I'm just going to create a little bit of space here because I don't have much space. So let me just erase some stuff and then I can get writing. So interpreting your b coefficient. Now in the formula, as you can see, for the value of y is equal to a plus bx, the b is attached to the x. So when we're interpreting, we are also going to interpret in a way that relates that b value to your x variable, because you are basically saying here, I did the actual calculation. So these were the actual calculations. For number 2, it was to determine the value of a and b in the equation. I just erased it actually from the top here. The one that I had done here, that was for the value of b, and then I did the value of a just below that. That's how we got the value of a here and b here. Okay, perfect. Okay, so as I was saying, in terms of the b coefficient, since it's attached to the x variable, we're going to sort of use it in our interpretation. So this is not something that's really commonly asked, but just in case you do get it, I have included it as one of the questions so that you are able to interpret if you, or in, yes, interpret that b coefficient if you're asked to do so. So if you look at the formula at the bottom that we had already generated just now, it says y is equal to 111, sorry, minus 111.68 plus 1.39x. So the 1.39 is your b value, which we already calculated using that formula at the top. So this is saying to you that this is the amount by which your x variable is going to, so I'm just going to write it here. Sorry, I need a little bit more space. I'm trying to see where, let me actually take this out. So let me just remove this and then I'll be able to write here because I want to write down the interpretation for you. So I'll write it down and then I'll explain it to you. Okay, so I've written down the interpretation for you for the b coefficient. So as I said, you have 1.39 as your value for b. Now you will use the fact that it's attached to x tells you that you're going to use x in your interpretation. And how you interpret this is that when your X variable, which in this case is your annual income, so you can also say, instead of saying when your X variable, you can say when the annual income changes by 1, then the Y variable, which is the vehicle value, changes by the 1.39, which is the value of B. So if I'm using the actual X and Y variables in that interpretation, I'm going to replace the words X variable with annual income, and I'm going to replace the words Y variable with your vehicle value. So this will be vehicle value, and that will be annual income. So if I had to use the actual variables, it'll say when the annual income changes by 1, then the vehicle value will change by 1.39. So the reason I'm not specifically saying increase or decrease is because it is possible that it will work in either way. So what it's basically saying to you is that if the annual income decreases by 1, then the value of the vehicle will decrease by 1.39. But it's also saying that if the income increases by 1, then the value of the vehicle will increase by 1.39. So it's in either direction, which is why I'm not being specific about an increase or decrease. So instead of just saying increase or decrease, I'm just using the word change. So when the annual income changes by 1, then the vehicle value will change by 1.39. So this is your interpretation of your B coefficient, and that's number 3 done here as well. Then for number 4, so number 4 says to you, what would a person be able to spend on a vehicle if their annual income was 235,000 Rand? So all you're going to do here is in the formula that we have calculated, which is this one here, y is equal to 100 minus 111.68 plus 1.39x. You're going to plug in place of the x in that formula, and I'm going to write out the formula again at the top so that we can work with it more easily where there is more space. So all you're going to do is, in place of x in the formula, you're going to plug in this 235,000 Rand. Now, remember, this was in hundreds of thousands of rands. If you look at the table as well, so I'm going to circle it for you in a second. I just want to erase. So if you look at this within brackets, it says hundreds of thousands. So the 000 here is indicating that it's in hundreds of thousands. So all you're going to do is, in the formula, y is equal to minus 111.68 plus 1.39x. You're going to substitute in place of x the 235,000 Rand that they said to you. This is what the annual income will be. How will that affect the amount that we can spend on a vehicle? So you're going to say y is equal to, and again, because it is in hundreds of thousands, what I'm going to do is I'm going to include the zeros here. So it'll be 111,680 plus, and then use your brackets here, 1.39 in place of the x. I'm going to put in the 235,000. Now, the reason I'm putting in this sign in the center, this here, is because, again, from the top, as long as there's no sign, you're going to automatically be multiplying. So here it's 1.39 times x, but there is no sign. You don't need to put a multiplication sign. So it's a given that it's multiplication. So it'll be plus, and then within brackets, it's 1.39 times 235,000. So now you will calculate this answer, and it tells you that y is equal to 214,970. So that tells you that if the annual income is 235,000 rand, 170. So that tells you that if the annual income is 235,000 rand, then the worth of the vehicle that you can purchase, or you can purchase a vehicle that is worth 214,970 rands. So remember, that is what they were asking you. If the income is 235,000, how much can you spend on a vehicle, basically? So here you're saying that if the income is 235,000, then you can spend 214,970 on a vehicle. All right, so that is question 4. Then question 5 says to you to calculate the correlation coefficient and interpret your finding. So the correlation coefficient is actually pretty similar to your formula for B. So the formula for B, and I'm going to show it to you now as well. The formula for B, it literally does not have about one component that your R value, your calculation of your coefficient, will have. So I'm just going to erase here. Okay, that looks a whole lot better. Okay, so in your formula for B generally, it says n multiplied by the sum of x, y minus the sum of x times the sum of y. And then in your denominator, you have n times the sum of x squared minus the sum of x then squared. Now, this is what the B formula is, what the formula for calculating the B coefficient is. Now, for the formula for R, the only thing that is going to change is in your denominator, you will make this a square root. You're going to put this that's already there into its own bracket, and then you're going to further multiply that by exactly the same thing that you did here, but where there's x, you're going to replace it with y. So it'll be n times the sum of y squared minus the sum of y then squared. And you'll close off that bracket. So that's the only change to the formula for R. So with the B formula, you just didn't have this part at the end here, and you didn't have the square root sign in your denominator. Everything else is the same. The formula for this, though, is in your formula sheet. So for your exam, you don't have to worry about knowing this formula. So here you have pretty much the exact same things that went into the formula for B that go into this formula. So I'm going to start writing that out. I'm going to write it out at the bottom of the screen because I don't have much space at the top. So here you have are being calculated as, and let's start plugging in the values. So it's n, which is 10. Remember, it's because you had a sample of 10. So it's 10 multiplied by the sum of xy, which is here. So that's 313409. And then you have minus the sum of x, which is here, 1879, times the sum of y, which is here, 1495. And then you have in your denominator, it's the root. And make use of your brackets here again, please. So you have the first set of brackets, which is n times, and again, within this, I have brackets as well. So it's n times the sum of x squared. Here is the sum of x squared, and its value is here. It is 376418. And then it's minus the sum of x, which is here at the bottom, That's 1879, and that's squared. Then you'll close off that bracket and open up the next set. Then again, another set of brackets. It's n times, as you can see here at the top, it is the sum of y squared. So here is the sum of y squared. And as I said, this is why we actually needed this column, because although we hadn't been using it all along, it is needed for this calculation. So the sum of y squared is 299,118, and then it's minus the sum of y, which is here, and that's 1495 squared. And you will close off that square bracket. Sorry, I see that there's a 2 here. It's not supposed to be there. It should be the sum of y. Okay, so that's 1495. And now you have everything that you need for the calculation. So when you calculate this value and you put it into your calculators, when you're entering it, so just in case you're having a difficult time with entering it onto the calculator, you're going to press that button that has the fraction sign like this. Then you're going to start at the top. So at the top, exactly as you can see it in this formula, you'll put in a bracket and say 10 times 313409, and then close your bracket minus, open your bracket, and it'll be 1879 times 1495. Close the bracket. Then you'll navigate to the bottom here, that small block at the bottom, and you are going to locate, I think it's somewhere below the down arrow, somewhere around there. It is an icon that looks like this. So I'm not sure, I can't remember for sure whether it is the icon itself or it's just above it. Let me just have a look. I'll tell you in a second. On the calculator. Okay, so next to the x squared button on your calculator, you'll see this one. So it's in the middle of the calculator. You'll see this one. So it's in the middle of the calculator. So next to the x squared button, you'll see that sign. You'll put that in, and then you'll use your arrows to navigate to this block on the inside. And then you can again make use of brackets exactly as you can see it here. So you'll put one bracket, and then you'll put another bracket. You only have the round brackets on your calculators. You won't have the square one naturally, but you'll just use the round one. So you'll press the round bracket, the open bracket, then you'll press it again, and then you'll type in the 10 times 376418, close it off, and then minus 1879 squared, and then you will close that bracket off, and then immediately you can. And again here, I would suggest just using the multiplication sign just to not get confused and go wrong anywhere. Remember, although there is no sign here at the top, as you can see here between these two brackets, there is no sign, but it's a given that it's multiplication. So you can put in the multiplication sign to indicate that it's multiplication. And then you have n times again. So here you'll make use of a double bracket again. 10 times 299,118, close the bracket, minus 1495 squared, and close the bracket again. So this should give you an answer of 0.77. And then when you calculate this, you do need to interpret it. So firstly, with this answer, it can either be a positive value or it can be a negative value. So it doesn't have to be only positive, it can be negative. So here, if it's a positive value, then you will say there is positive correlation. If it's a negative value, you'll say there is negative correlation, or the two values are negatively correlated. Then you can also have the value being closer to 0, or closer to 1 if it's positive, or it can be closer to -1 if it's negative. So it can either be, and I'm just going to write it on the next page for you. It can either be, and this is the best way to explain it, it can go from -1 to 0 to 1. So the closer it is to 0, the weaker it is. The closer it is to 1 or -1, the stronger it is. And then if it's between 0 and -1, it's naturally a negative value. If it's between 0 and 1, it's a positive value. So this is how you would interpret your correlation coefficient. If it is a positive value, then it will be positive correlation between the two variables, meaning that they are both increasing and decreasing at the same time. They both basically move in the same direction. And then with your value itself, if it is a positive and it's closer to 0, then it's a weak, strong, or sorry, a weak positive correlation. If it's closer to 1, then it's a strong positive correlation. The same with if it's a negative value. That means there's a negative relationship between the variables, meaning that they move in opposite directions to each other. So here, if it's negative and it's closer to 0, like for instance, -0.08 is your answer, then it's a weak negative relationship. If it's closer to the number 1, so for instance, -0.86, it's closer to -1, that would mean it's a strong negative relationship. Okay, so in this case, our answer is 0.77. So firstly, it is a positive value, and then it's closer to 1 than it is to 0. So that would mean it is a strong positive correlation, or that there's a strong positive relationship between the variables. And then your last question at the bottom, number 6, is to calculate the coefficient of determination and explain your answer. So the coefficient of determination is going to be this R value that you had calculated here at the top. So this one here, it's squared. So whatever answer you get for R, all you're going to do is square it. So for this question, remember R we calculated at the bottom here was 0.77. So if you square 0.77, and I'll write it here, 0.077 squared, that's going to give you an answer of 0.59, which needs to be converted to a percentage. So that's 59%. So your coefficient of determination is 59%. I'm just going to delete that and write it again so I can have some space. So R squared, which is your coefficient of determination, is 0.77 squared, which is 0.59 as a percentage. That was 59%. So here to interpret that, this is telling you how much X explains Y. So it's basically saying to you that you have two variables, X and Y. X is your annual income, Y is your vehicle value. So it's saying to you that any change in the annual income is going to explain 59% of why the vehicle value changes. So it's explained as follows. You can say it in a very quick and easy way. You can say 59% of the changes in the vehicle value are explained by changes in the annual income. Okay, and that is it for today's session. Any questions? Anything you're confused about? No, so n is how many values there were that were given to you. So here, as you can see, there are 10 values. So n is equal to 10 in this case. It's the number of values that are provided to you. Okay, perfect. Thank you. Enjoy the rest of your evening. Please make sure that you're trying out the question that you see up here. So section B, pretty much the same as section A. The calculations are exactly the same. Naturally, just the figures are different. But the way in which you go about calculating A, B, R squared is exactly the same. Same formulas used. So use what we've done in section A to practice with section B, get a feel for it. Also make use of your calculators, just practice and gauge whether you're comfortable enough with entering these values onto your calculators. Also, when I have uploaded the worksheet on your calculators, play around with it so that you're comfortable with how to make use of the functions that are available on your calculator. And if you have any questions, please pop me an email. I'm happy to assist. I shall see you again soon. We have our NSS session soon, so I will send you guys an email regarding that. Other than that, enjoy the rest of your evening, and I'll chat to you again soon.